So today we are going to be solving Cambridge IGCSE Chemistry Paper 4 Theory Extended February-March 2025 Paper 42. This is the most latest and recent paper we have for chemistry, and this is a difficult paper. So if you guys are able to solve this paper, then probably you're going to be able to solve the O-levels paper as well, because Cambridge IGCSE and Cambridge O-level syllabus is exactly the same, and 2025 O-levels May June is going to be similar to this because this is the latest paper we have. So let's get started. Okay, by reading question number 1, using numbers only, state the percentage of oxygen in clean dry air. Okay, you should learn the percentage by composition of all gases in air. Nitrogen is 78%, oxygen is 21%, carbon dioxide is 0.04%. Okay, just learn these are very important. So for oxygen, it's gonna be 21%. Okay, typical operating temperatures in degrees Celsius used in the Haber process. Okay, just learn the temperature, the pressure, everything for Haber process. Iron catalyst is used, learn for contact process as well. Remember that in Haber process we use 450 degrees Celsius of temperature, and similar temperature is used in contact process as well. Both processes use similar temperatures, so it is going to be 450 degrees Celsius. Okay, using numbers only. So if it's fine if you don't write percent or degree Celsius, it's going to be totally fine. Okay, you can only write numbers, so that's fine. But even if you write percentage or degree Celsius, it's not going to be considered wrong. Okay, the number of atoms in a diatomic molecule. Diatomic basically means that in one molecule you have two atoms. Okay, diatomic means that this is one molecule, and in this molecule you basically have two atoms that are covalently bonded to each other, and you have these diatomic molecules in your halogens, in your fluorine, which is F2. F2 means that it's a diatomic molecule. There are two fluorine atoms together that are covalently bonded. So diatomic basically means that you are having your two atoms in one molecule. Okay? The maximum number of electrons in the second electron shell of an atom. Okay? You should know the maximum capacity of electrons in the first shell of an atom is 2, and the maximum capacity of the second shell is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So the answer is going to be 8. Let's move on. The number of hydrogen atoms in an alkane with 7 carbon atoms. Okay? We have to reduce the number of hydrogen atoms in an alkane. This is the keyword, with 7 carbon atoms. Okay? First, let's write down the general formula of an alkane, which is CN H2n plus 2. Okay, this is the generalized formula of an alkane that you guys must know. This N is basically the number of carbon atoms. Okay, and in this question they've told us that we have 7 carbon atoms, so that means that in place of N we put a 7. Okay, and now hydrogen is 2N, means 2 times 7 plus 2. So 2 times 7 is going to give us 14, and plus 2 is going to give us 16. So the number of hydrogen atoms in an alkene with 7 carbon atoms is going to be 16. Okay? And if you are good at mental maths, you should know that hydrogen is basically the double of your carbon, and then you add 2 into it. Okay? First you double your carbon. Carbon is 7, you double it, that's 14, and then you add 2 to it. Okay? That's simple mental maths. In an alkane. Okay? For alkenes you're going to have a different general formula, so it's very important that you read what's written in the question. Okay? Let's move on. The number of particles in 1 mole standard form. Okay? The number of particles. Now after recent syllabus change, it has been added to the syllabus that you should know that 1 mole contains 6.02. This 02 is very important. Okay? Because this is written in the syllabus that this 02 should be with 6.02 into 10 exponent 23 particles. Acha, one important thing over here is that what do they mean by standard form? Standard form basically means this is the standard form. Why this is standard form? That this number, okay, the first number should be from 1 to 9. Okay? This first number should be from 1 to 9, and the decimal should be placed after the first letter, which can vary from 1 to 9. ठीक है, अगर यहाँ पे 26 होता, if it was 26, this is not standard form. Why this is not standard form? Because this number before the decimal should be from 1 to 9. ठीक है, so if you guys are taking maths as well with chemistry, you should know what is standard form and you should learn this. ठीक है, इससे हमारा formula भी एक drive होता है, the Avogadro's formula. This is known as Avogadro's constant. ठीक है, so learn it. 6.02 into 10 exponent 23 particles are present in 1 mole of any substance. Let's move on. This question is about ionic bonds. ठीक है, state what is meant by the term ionic bond. अच्छा देखें, अब in ionic bonds what you guys have is basically your positively charged ions and your negatively charged ions. ठीक है, and these both ions are basically attracted towards each other by strong electrostatic, the word is very important, electrostatic forces of attraction which hold these oppositely charged ions together. ठीक है, there is a force of attraction holding the positively charged and negatively charged ions. That's where the name ionic bond comes from. You have ions, you have positive ions, you have negative ions, and there's force of attraction between these two, and this force of attraction is called electrostatic force of attraction. So your ionic bond, ठीक है, if you just learn the the definition from syllabus as well and you understand this concept, so ionic bond is basically the electrostatic force of attraction holding the oppositely charged ions together. ठीक है, this is very important that देखें, when you have a positive and negative, they always attract, you should know. ठीक है, so basically this is the force of attraction between the oppositely charged ion, and the name electrostatic is important because this is the type of attraction which is present. ठीक है, let's move on. Potassium sulfide K2S is an ionic compound. ठीक है, complete the dot and cross diagram in figure 2.1 of the ions in potassium sulfide. Show the charges on the ions. ठीक है, before completing the diagrams, you should know the charges. Potassium, you should know, is in group 1, so it's going to have a charge of +1, or you can write plus. ठीक है, and now we have two potassium, this potassium and this potassium. ठीक है, because it's K2S. K2S means with a single sulfur you are having two potassium, so this is going to be a plus over here and a plus over here. ठीक है, now we're done with the charges. ठीक है, of potassium. Now let's move on to sulfur. You should know that sulfur is in group 6. ठीक है, if you don't know, there's a periodic table out there, no need to worry, you can check it out, but simply by looking at this formula, ठीक है, this K2S, simply this tells us that देखें, इसके नीचे 1 होता है. ठीक है, when there's nothing, there's 1. This 1 is basically +1 is basically the charge of potassium, and this 2 beneath this is the charge of sulfur, so it's a -2. ठीक है, so that's simple and easy to understand. So, and you should know sulfur is in group 6, so it's going to be a 2 negative. ठीक है, remember you don't write -2, this is not the correct way, you write 2 negative. ठीक है, that's how you write it. Now we have to complete the dot and cross diagram. अच्छा, अब देखें, what's basically happening is, how is the sulfur basically getting this 2 negative? How is the sulfur getting it? 2 negative means that it has 2 more electrons than protons. That means that it has gained 2 electrons. And what do you mean by this +1? +1 means that you have 1 less electron and you have 1 more proton. So what basically happening is that 1 electron potassium is losing. ठीक है, potassium is losing 1 electron. How is it losing? Because it has a charge of +1. And this potassium is also losing 1 electron. And this sulfur, because it has a charge of 2 negative, is gaining 2 electrons. ठीक है, I hope that makes sense. And that means that to complete the dot and cross diagram for sulfur, it has gained 2 electrons from potassium. ठीक है, 2 electrons. This statement is very important, from potassium, because this is going to make us understand that देखें, अब now the electrons of potassium are a dot. So that means that in sulfur's last shell, which is going to be this one, we have to complete it. देखें, group 6 में है, तो 6 तो it's going to have 6 its own electrons. 6 though it's gonna have its own. So 6 crosses 1, 2, 3, 4, 5, 5 and 6. But the problem is now it has gained 2 electrons to get 2 electrons from 1 electron from 1 potassium and 1 electron from 1 potassium. So now you need to show 2 dots in sulfur's last atom. Okay? These 2 dots carry marks. These are very important. This shows that sulfur has basically gained 2 electrons from the potassium. And now in potassium lost cell, because potassium has simply lost electrons, it has gained nothing. So it's just going to be dots. Okay? And you can check it out from the periodic table. Because sulfur was 16 matlab 16 there were 10 crosses. We drew 6 more crosses. Okay? Initially these were 10. They came 1 2 3 4 5 6 7 8 9 10. We drew 6 more and we made it 16, and 2 basically it gained in this chemical reaction which just occurred. So 2 we drew more. Okay? So I hope you understand this thing. Now let's move on to potassium. Potassium has basically 19. 19 means that 19 is the proton number, 19 electrons as well. You can check it out from the periodic table, and it lost 1, so that means now it has 18. And over here in the diagram we are given with 10, so that means we have to draw 8 more. So 1 2 3 4 5 6 7 8. Similarly over here as well we're going to draw 8 more. 1 2 3 4 5 6 7 8. To get done with it, the important thing over here was these 2 electrons to get of potassium, which are now part of sulfur, because sulfur has basically gained these 2 electrons. Okay, let's move on. These 3 marks, in order to get these, you got to show all these things. Okay, let's move on. Ionic compounds form giant ionic lattices. Okay, figure 2.2 shows part of the giant ionic lattice structure of sodium chloride. Complete the diagram in figure 2.2 to show the ions present. Use a positive for sodium ions and a negative for chloride ions. One chloride ion has been completed for you, this one. Now the important thing over here is the formula of sodium chloride, NaCl. NaCl tells us that there are equal number of sodium and chloride ions in this ionic lattice. That means that if we have this negative, we are going to have equal positive charge in it as well, okay? Because we have Na, one Na and one Cl, okay? And now important thing over here is the opposite charges attract, okay? The thing is that opposite charges attract. So this negative charge on all its side is going to have a positive charge, okay? Now it's basically connected to 3 things, okay? Yahan se this negative chloride is connected. There's one connection of this chloride from here and one from here. So both these all these 3 connections are going to have a positive, okay? Because opposite charges attract, this chloride ion is going to be attracted to sodium, okay? So a positive here, इस कनेक्शन पे भी एक पॉजिटिव आएगा, इस पे भी पॉजिटिव. क्यों पॉजिटिव? क्योंकि यहाँ पे नेगेटिव है. नेगेटिव मीन्स ऑल 3 इट्स अट्रैक्टिंग आर गोना बी पॉजिटिव. अच्छा, अब ये पॉजिटिव है तो मतलब यहाँ पे इसके साथ नेगेटिव आएगा, ये भी पॉजिटिव है, यहाँ पे भी नेगेटिव. अब ये वाले पॉजिटिव से बेसिकली दिस पॉजिटिव इज़ गोना बी अट्रैक्टेड टू यहाँ पे इस साइड पे भी नेगेटिव, और ये क्योंकि नेगेटिव है तो मतलब इसके इस साइड पे आएगा पॉजिटिव, ठीक है? और इसके भी साइड पे आएगा पॉजिटिव, तो यहाँ पे पॉजिटिव, और ये पॉजिटिव है तो इसके नीचे यहाँ पे आएगा नेगेटिव, ठीक है? जस्ट सिंपल ऑपोजिट थिंग यू हैड टू डू. गोना बी नेगेटिव, दिस इज़ गोना बी अ पॉजिटिव and this is going to be a negative, ठीक है? If you didn't understand from this method which I've told, you could just simply see that you just had to complete these, ठीक है? 4 on all sides, ठीक है? यहाँ पे भी 4 कंप्लीट करने थे, यहाँ पे भी 4 कंप्लीट करने थे, बस जस्ट बाय लुकिंग के ऑपोजिट होने चाहिए, ठीक है? दिस नेगेटिव कैन नॉट बी अट्रैक्टेड टू अ नेगेटिव. अगर यहाँ पे नेगेटिव होता तो इट्स रॉन्ग, ठीक है? नेगेटिव नेगेटिव रिपेल, बेसिकली ऑपोजिट चार्जेस अट्रैक्ट, सो वी जस्ट हैड टू लुक फॉर ऑपोजिट चार्जेस. State the name given to any positive ion. Positive ions are basically called cations and negative ions are called anions, ठीक है? That is a basic information, ठीक है? Part of basic information, ठीक है? Ionic compounds can be decomposed by the passage of electric current using inert electrodes. State the name of this process. ठीक है. So what you're passing electricity. ठीक है, you're passing electric current and you're using electrodes. So what is this process called? That's simple and easy. That is your electrolysis. ठीक है, in electrolysis what you do is you take a beaker, not a beaker, a container, and then you have your electrodes, and then you pass electricity from the solution and you break it down. ठीक है, this is an ionic compound solution. Either this is molten or aqueous, and basically by using this electrolysis process you break down your ionic compounds. ठीक है, write the ionic half equation for the reaction which takes place at the anode when molten potassium bromide is decomposed by the passage of an electric current. Acha. Now the thing is that whenever they've given you ionic half equations, first you got to realize what kind of thing you are decomposing. Over here they've highlighted this molten word, that it's molten potassium bromide. ठीक है, molten potassium bromide means that the only two ions you're going to have in molten potassium bromide are going to be K plus ions and B or negative ions. You should know that we have to write the ionic half equation which takes place at the anode. At the anode you always have negative ions, so we're going to have our bromide ions being discharged at the anode to form bromine gas or bromine liquid. So what is going to be the half equation? You're going to have your bromide ions, B are negative. Okay, first thing is to identify what's going to happen is that they're going to turn into simple bromine gas. But the problem is that देखें यहाँ पे if you see it clearly, there is this negative charge. ठीक है, there is this negative charge. Negative charge means that bromide ion basically right now has one more electron, and now over here when there is no number, that means there is a zero over here. ठीक है, over the top of bromine gas you have a zero. That means that this negative charge you have lost. ठीक है, you have lost this negative charge, so that means you're going to form electron as well. ठीक है, now the problem over here is bromine is diatomic. Two atoms that are covalently bonded to form a molecule. So true bromide ions would form a bromine atom, a bromine molecule, and then you're going to have two electrons. ठीक है, so that's how you write ionic half equations. अच्छा, name the products and state the observations at the negative and positive electrodes when dilute aqueous potassium bromide KBr is decomposed by the passage of an electric current. Product at the negative electrode. Acha, the thing to know over here is that negative electrode is your cathode. ठीक है, negative electrode is your cathode. So just label it so that it's easy. This is your cathode. This way, because negative positive confuses, cathode anode is not confusing, and the positive electrode is basically your anode. ठीक है, अच्छा, now what they're asking is the product at the cathode. So we have dilute aqueous potassium bromide. ठीक है, dilute and aqueous means that it is going to have H plus. Aqueous basically means it's going to have water, so it's going to have H plus in which negative ion, and KBr means that it's going to have a potassium ion and a bromide ion. ठीक है, अब ये 4 ions हैं हमारे पास. ठीक है, in this solution we have these 4 ions. Basically on the cathode positive ions discharge. What do you guys think out of these 2 ions which is going to discharge, hydrogen or potassium? देखें, I'm going to tell you the less reactive ion. ठीक है, the more less reactive you are, the more easier for it is for you to discharge. So less reactive will discharge. Less reactive discharges. So who is more less reactive, hydrogen or potassium? Obviously hydrogen is less reactive, so at the negative electrode the product is going to be hydrogen gas. ठीक है, an observation is going to be a colorless gas seen. ठीक है, the next thing is the product at the positive electrode, which is the anode. अच्छा, अब यहाँ पे देखें, they have given us 2 lines. They have given us this line and it is written and in between, and then we are given with this line. This means that we have to write 2 products. ठीक है, and we have 2 ions, bromide ion and hydroxide ion. Hydroxide ion basically always discharges to form oxygen gas. ठीक है, hydroxide always discharges to form oxygen gas, and obviously bromide is going to discharge to form bromine gas. अब हमारे पास 2 है, so we're gonna discharge both. We have to discharge both because this question was, it's not written over here, but it was 5 marks. So 1 mark for this, 1 mark for this, 1 mark for this, 1 for this, and 1 at last it's written observation at the positive electrode. So 1 for this. So a total of 5 marks. That means we have to fill these two, both this and this. So it's going to be oxygen and bromine. ठीक है, अगर ये खाली it would have been 1 because it's a dilute solution, तो फिर we would have written oxygen, because in dilute solutions you never form your halogen. ठीक है, bromide is halogen. In dilute you always form oxygen, but over here we have 2 blanks, so we have to fill. So we're going to discharge both oxygen and bromine. An observation, because bromine is reddish brown, so observations at the positive electrode is going to be reddish brown vapor seen. Okay, so we're done with this. Let's move on. The halogen are a group of elements in the periodic table. Okay, we know it, group 7. Chlorine is a member of this group. Okay, we also know this. State the group number of halogen. The group number of halogen is 7, and in brackets you can write VII 5, 6, 7. That's the group number. Okay, state how many halogens are there in this group. In order to check this, let's visit the periodic table to check how many halogens are there in this group. So this is basically the periodic table. Okay, so we have this 1 halogen, which is fluorine, 2, 3, 4, 5, and 6. So we have a total of 6 halogens in group 7. So we're gonna write 6 over here. How many halogens are there in this group? 6 halogens. Okay, suggest the identity of the halogen with the highest density. अच्छा, अब always remember that down the group in halogens your density increase. This देखें, this is fluorine, this is chlorine, this is bromine, this is iodine. So down the group the density increases. Suggest the identity of the halogen which has the highest density. So which is going to be the lowest in the periodic table. Okay, this is the periodic table. Down the group, okay, as you basically move down the group your density increases. Okay, so what that means is that this halogen is going to be having the highest density, and this is going to be having the lowest density. Okay, because as you move down the group your density increases. So this is tennessine, whatever this is this is going to have the highest density. Acha. And there are 2 trends included for halogens in the syllabus. One is density, the other is reactivity. Always remember, down the group your density increases, but your reactivity down the group is going to decrease. As you move down the group the reactivity decreases. What do I mean by that? That this Tennessee thing, which is going to have the highest density, is going to be the least reactive, and the most reactive is going to be the top halogen. So what is most reactive? Fluorine. And least dense, fluorine, and most dense, this Tennessee thing, and least reactive also this tennessine thing. Okay, okay, so has the highest density, so we know that it's going to be that tennessine thing. अच्छा, ठीक है, is the most reactive. हमने अभी डिस्कस किया the top halogen is the most reactive. ठीक है, और down the group reactivity decreases, तो top one is the most reactive, so it's going to be fluorine. ठीक है, state the name of the negative anions formed by halogens. They're called halides. Iodide, bromide, chloride, they're all halide ions. So they're halides. Halides of the salt, you can write halide ions. Okay. Okay. State how many occupied electron shells are in bromine atom. Okay. In order to check the occupied electron shells, basically you check the period number in the periodic table. How do you check the period number? देखें. In your periodic table, you have these rows. Okay. These are your rows. Okay, and these are also called periods, and the period number basically tells how many occupied electron shells you're going to have. This is your period number 1. This means all the atoms in this row are going to have 1 shell. This is your period number 2. This is your period number 3. This is your period number 4. And bromine is in period number 4. That means bromine is going to have 4 occupied electron shells. Chlorine is going to have 3 occupied electron shells. Fluorine going to have 2. And helium going to have 1. Why? Because the period number tells that all atoms in that period will have the same number of shells, occupied electron shells, as the period number. So basically, this bromine is going to have 4 occupied electron shells. So how many occupied electron shells are there in a bromine atom? There are 4 shells. Asha, name the noble gas that has a similar electronic configuration to a bromide ion. Asha, for this we need to go to the periodic table again. ठीक है, अभी ब्रोमीन के पास 35 इलेक्ट्रॉन्स भी हैं और प्रोटॉन्स भी हैं. ठीक है, ब्रोमीन has 35 electrons. Now when it forms a bromide ion which is B or -1, that means it gains 1 electron. ठीक है, what do I mean? That देखें, it's basically an atom right now. It has 36 electrons and 36 protons, but when it forms a bromide ion Br1 negative, that means it has 1 more electron. It has basically gained 1 electron. Okay, now that means that it's gonna have 36 electrons. Okay, and what do you guys think? Which atom of noble gas has 36 electrons? This one. The proton number is 36, that means electron number is going to be also be 36. So a bromide ion, when it gains 1 electron, is going to have similar electronic configuration to krypton. Okay, because krypton also has 36 electrons, so it's going to be krypton. Okay, aqueous chlorine Cl2 reacts with aqueous potassium iodide. One of the products formed is iodine. Complete and balance the ionic equation for this reaction between chlorine and iodide ions. State symbols are not required. Okay, state symbols, basically these are your symbols like aqueous, solid, liquid. These are your state symbols. Okay, we don't have to write it. Acha, basically chlorine, because it's more reactive, so it's gonna displace bromine. And देखें, यहाँ पे chlorine है and यहाँ पे it's gonna form ions. They're gonna be chloride ions, and because there's a 2 over here, you add a 2 over here, and over here they're gonna be 2 iodide ions forming iodine. Okay, these are iodide ions. This is iodine. These are chloride ions because it has a negative, and this is basically your chlorine. Okay, explain why this reaction is defined as a redox reaction. Simply gain and loss of electrons. Give your answer in simple terms of electron transfer. Okay, you're gonna say that iodide ions, these iodide ions, they're losing electrons. Okay, -1 say their oxidation number going to 0. So that's basically a loss of electrons. You're gonna say that iodide ions lose electrons to form iodine, and there, because we have to use in terms of electron transfer, so we're going to say that their electrons are transferred to chlorine, which gains electrons to form chloride ions. That was simple. के देखें, यहाँ पे क्लोरीन का ऑक्सीडेशन नंबर 0 है, यहाँ पे है -1. ठीक है, that means 0 to -1, that's a gain of electrons. Chlorine basically gained the electrons from iodide, because iodide basically lost. ठीक है, so to form chloride ions. ठीक है, give the color and state of iodine at RTP, room temperature and pressure. Color of iodine, you are going to learn the color of halogens. For I'm just going to write it over here, just learn it. For chlorine, it's a pale yellow-green gas. Learn it. Pale yellow-green. I know this is going to be tested. Okay? For chlorine, it's a pale yellow-green gas. For bromine, these 3 are included. For bromine, it's a red-brown liquid. Learn it. Okay? And for iodine, it's a gray, black, solid. State is solid. For chlorine, the state is a gas. For bromine, it's a liquid. And then for iodine, it's going to be a solid. Okay, let's move on. Carbonyl chloride, COCl2, is manufactured by reacting carbon monoxide with chlorine. Carbon monoxide, chlorine, carbonyl chloride. Okay, and that's the enthalpy change, which is negative. That means the forward reaction is exothermic. That tells us that backward reaction is going to be endothermic. Achha, this is not needed, but you should know whenever the forward reaction is exothermic, the backward is endo, and if the forward is endo, the backward is exo. Okay, that should be a understood thing for you guys. The process takes place in a closed system. Closed system means that nothing is entering it or nothing is leaving it. It's a closed system and equilibrium is reached. The conditions for this process are 200 degrees Celsius and 200 kilopascals of pressure. Explain what is meant by a closed system. Nothing enters or leaves the system. Okay? State what is meant by delta H. Delta H is simply your enthalpy change. Enthalpy change can be negative or positive. In this case, it's negative. Okay? State how the value of delta H shows that the forward reaction is exothermic. Delta H is negative. Okay? This negative sign with negative 105 tells us that this negative 105 tells us that this is an exothermic reaction because energy is being released. Greater energy is being released than absorbed. Okay? Deduce the value of delta H for the reverse reaction. Include a sign in your answer. Okay, forward reaction, I just told you right now that if your forward reaction is exo, that means backward is endo. And if the delta H for forward is negative 105 kilojoules per mole, then for the endo backward reaction, the reverse reaction, which is endo, it's going to be a positive 105. Because the amount of energy released according to the law of conservation of chemical energies, basically the amount of energy released to form the product, the same amount of energy is absorbed back to form the reactant. So it's going to be a positive 105 because your reverse reaction is endothermic and the same enthalpy change but positive. So reduce the value of the enthalpy change. It's going to be a positive 105 kilojoules per mole. Complete table 4.1 to show the effect, if any, on the concentration of carbonyl chloride at the equilibrium when the following changes to the condition are applied. Use only the words increase, decreases, or no change. These are the changes. We have to write what will happen to the concentration of carbonyl chloride at equilibrium. Temperature is increased. अच्छा, अब देखें forward reaction exothermic है. Forward reaction exothermic है. So if you increase the temperature, so what will happen is that देखें जब try to understand that whatever you do to the equilibrium tries to reverse it. So if you increase the temperature, equilibrium tries to decrease it. And how will equilibrium do that? By doing the endothermic reaction. So when endothermic reaction will happen, backward reaction, the carbonyl chloride will decrease. You increase the temperature, equilibrium tries to decrease it. In order to decrease the temperature, obviously it's going to do the endothermic part. And when equilibrium moves backward, your carbonyl chloride decreases. So when the temperature is increased, the carbonyl chloride decreases. Some CO is added. Whatever you try to do, equilibrium tries to reverse it. Some CO is added. Now what you have done, you have increased CO. And when you have increased CO, equilibrium tries to decrease it. So in order to decrease this, equilibrium forms more of the carbonyl chloride, more of the reactant, it moves forward. So your carbonyl chloride increases. Why it increases? Because you added CO. Because you increased it, equilibrium will decrease it. And in order to decrease it, it will move it forward so that this decreases. So basically your amount of carbonyl chloride will increase. So and we are concerned with the concentration of carbonyl chloride, so it will increases. Pressure is increased. Now pressure has to do with the moles of gases. Okay, pressure only affects the moles of gases. Now let's look at our equilibrium and see how many moles of gases we have. On this side we have 1 mole of gas and 1 mole of gas. That makes a total of 2 moles of gases. Okay, on this side we have 1 mole of gas. On this side we only have a total of 1. Equilibrium, basically, if you increase in pressure, moves the equilibrium to the side with less moles, and a decrease in pressure, this is an inverse relation kind of, you can think that it moves the equilibrium to the side with more moles. Over here what we're doing is we are increasing the pressure. Okay, we are increasing the pressure, so equilibrium will move to the side with less moles. Okay, we're increasing the pressure, so equilibrium will move towards the side with less moles. Over here we have 2 moles, over here we have 1 mole, so equilibrium will move forward and more carbonyl chloride will be formed, so its concentration increases. So we write that the concentration of carbonyl chloride basically increases. Now other thing over here is a catalyst is added. Always remember, catalysts do not affect the concentration of the products or reactants at the equilibrium, so we're going to use the third thing, which was no change. So a catalyst does not affect the position of the equilibrium. A catalyst only affects the rate of reaction. Okay, if we add catalyst, the rate increases but not the position of the equilibrium. Okay, let's move on. The equation for the reaction can be represented as shown in figure 4.1. Okay, this is the equation. Table 4.2 shows some bond energies. Okay, use the bond energies in table 4.2 to find the value of delta H for the reaction to calculate the bond energy in kilojoule per mole for carbon dioxide bond. Okay, we don't have the value for carbon dioxide bond. Basically, this is what is happening. Okay, use the following steps. Calculate the energy needed to break the bonds. Okay, always remember that these are your bonds, and when you break the bonds, you basically absorb energy goes in. Okay, so you need the energy to break this bond and this bond, because these two are your reactant. So in order to energy to break the bonds, you have one carbon triple bond with oxygen, so it's going to be 1075, and you have one basically Cl bond, so it's going to be plus 240. Okay, when you break bonds, you absorb energy. So just simply on calculator do 1075 plus 240, and that's going to give you 1315 kilojoules per mole energy. That's kilojoules, you don't write per mole, just kilojoules. Energy 1315 kilojoules energy absorbed to break the bonds. Okay, calculate the energy released when the bonds in the carbonyl chloride are formed. Okay, now you release energy when you are forming bonds. Okay, energy is coming out. So basically you have two carbon chlorine bonds. Okay, you have two carbon chlorine bonds. This is your first carbon chlorine bond, this is your second carbon chlorine bonds, and you have one carbon oxygen double bond. Okay, this is a double bond, and you have two single bonds with chlorine, so it's going to be 2 times single bond with chlorine, which is this carbon chlorine, which is 340, plus 1 times carbon oxygen bond. Because we don't have the value for it, we can write x. So right now we don't have value for x, so we cannot find the energy released when the bonds are formed. So let's move on to the next part. Next part is going to surely help us. Okay, calculate the bond energy of carbon triple bond. Once we get this bond energy, then we can plug in the value of x to find the total energy released. So basically, how do we get the bond energy for a carbon double bond is going to be energy. How do we get the value for enthalpy change? Energy absorbed minus energy released. Energy absorbed is when bonds are broken, energy released is when bonds are formed, equals to your delta H. अच्छा, अब energy absorbed तो हमारे पास 1315 थी, we calculated out. Energy जो release हुई थी वो 2 times 340 plus x थी. ठीक है, 2 times 340 क्या होता है? 2 times 340 let me show it. ठीक है, it's 680 plus x. Okay, we don't have the value for x, so just we write 680 plus x. X is basically the bond energy for carbon double bond oxygen, which we don't have. So this gives us the enthalpy change, which is negative 105. Okay, this is given in the question. Okay, negative 105 was given in the question. Okay, so this is negative 105. Now this is a simple mathematical equation. If you solve for the value of x, try to solve for the value of x, and you're going to get it 1315 minus 680 minus x equals to negative 105. X comes here, negative 105 comes here, 1315 minus 680 plus 105 equals to x. Just get the value for x, 1315 minus 680 plus 105 and 740. 740 is the value for carbon double bond oxygen. Okay, that was simple. Carbon double bond oxygen is going to be 740. Okay, अब यहाँ पे instead of x we can plug in 740, so it's 680 plus 740, and that's going to give us plus 680 1420. So this is 1420. Ab Asha, you can check your answer by subtracting these two, and you should get negative 105. That is the enthalpy change. Okay, do it. It's going to be 1315 minus 1420, and you're going to get negative 105. That means your answer is correct. Asha, let's move on. Complete the dot and cross diagram in figure 4.2 of a molecule of carbonyl chloride. Okay, show the outer electrons only. Okay. Basically, we know that in carbonyl chloride there was a double bond with oxygen and single bonds with chlorine. Okay, carbon double bond with oxygen, single bond with chlorine. We're just going to do the same thing. Double bond with oxygen, single bond with chlorine. Now one thing important over here is that we have to draw all outer shell electrons. Okay, chlorine is in group 7. Okay, group 7 means that one electron of chlorine is used in bonding. There are going to be 6 left, so we have to draw those 6 as well. 1 2 3 4 5 6. One used in bonding over here. Okay, 1 2 3 4 5 6. Oxygen is in group 6. That means 2 are used in bonding. How many are going to be left? 4. Okay, 6 minus 2, 4. So 1 2 3 4. We have to draw these are basically called your lone pair of electrons, or you can say the electrons that are not used in bonding. And in order to gain these 3 marks, you got to draw both the lone pairs as well as the bonded parts. Okay, let's move on. Manganese is an element with atomic number 25 in the periodic table. Okay, calcium is an element with atomic number 20 in the periodic table. Okay, atomic number basically tells you a number of protons. Okay, atomic number tells you a number of protons. Okay, so now we are given with the proton number of manganese and calcium. Now basically they've asked for the protons in the table. So simple, this is the proton number, 25 for manganese, 20 for calcium. Neutrons, this is your mass number. Okay, this is your mass number, the total number. 55 minus 25 is going to be your number of neutrons. Okay, 55 minus 25, that's going to give me 30 over here. And for over here, this is 42 minus 20. Okay, 42 minus 20, and that's going to give me 22 over here. Important thing is that this was the atomic number. Okay, atomic number means the proton number, so we just had to write it in the table. अच्छा, अब electrons पे आ जाएं. Because ये एक neutral manganese का atom है, so जितने इसमें protons हैं उतने इसमें electrons भी होंगे. Electron proton number same, so 25. But this is not a neutral atom. This is an ion. Ion means that unequal number of protons and electrons. ठीक है, 2 plus ion means 2 more protons. ठीक है, 2 more protons, 2 more positive charge. That means that देखें, अगर protons 20 हैं and there are 2 more protons, तो electrons कितने होंगे? 20 minus 2 now, so 18. Electrons are going to be 18 in calcium ion. ठीक है, so you got to be careful about these charges on the ions. Let's move on. Manganese form several oxides. ठीक है, this question is tricky. The formulae of some of these oxides are shown. ठीक है, MnO, Mn2O3, Mn3O4, MnO2, Mn2O7. Suggest why manganese is expected to form colored oxides. Colored oxide was a property of your transition elements because it is a transition element, so you can expect it to form colored oxide. Okay, state which other property of manganese is shown by the formation of several oxides. देखिए, इसमें manganese का charge क्या है? It's a 2+. Why it's a 2+? Oxygen 2 negative है. इसमें manganese का charge क्या है? ऑक्सीजन का 3 इधर आ जाएगा, सो इट्स 3 प्लस, और इसका 2 इधर आ जाएगा, 2 नेगेटिव. ऑक्सीजन हमेशा 2 नेगेटिव ही रहता है. सो ओवर हियर ऑक्सीजन, इसमें क्या चार्ज है? कैन एनीवन ऑफ यू फिगर आउट इन दिस पार्ट? देखें, इट्स सिंपल. ऑक्सीजन हमारा 2 नेगेटिव है, and there are 4 oxygens, so that means basically this is I would like to tell you that this is basically formed from these two. ठीक है, जब in an ore of manganese in which both of these are found, then you make this formula. ठीक है, so basically this formula, because I saw an MCQ as well in which it was a bit confusing like this formula is formed when you combine these two. ठीक है, so basically that is Mn3O4. so you don't get for this it's going to be a +4 for manganese. Why? because देखिए ऑक्सीजन 2 नेगेटिव है, 2 ऑक्सीजन है, तो मतलब टोटल 4 नेगेटिव हो गया, इधर +4 है, and it is going to be a +7 for manganese. ठीक है, so these are the oxidation number of manganese and they are variable. Why they are variable? because it is an transition element. State which are the property of manganese by shown. It's going to be a variable oxidation numbers, or you can say variable oxidation states instead of numbers. State the formula of manganese 2 oxide. देखिए manganese 2 का मतलब है manganese 2 plus, oxygen is 2 negative, same charge, opposite charges, equal charges cancel out, so the formula is going to be not Mn, sorry, it's Mn, it's not Mg, it's Mn, MnO. so that's going to be the formula of manganese 2 oxide. ठीक है, 2 means, this 2 means in the Roman numerals, this 2 means a 2 plus charge. ठीक है, MCO4 is found in an ore of manganese. Manganese metal can be extracted from M3O4, ठीक है, using aluminum as a reducing agent. Define the term reducing agent. Reducing agent is basically what itself oxidizes and reduces an other substance. An oxidizing agent is which itself reduces and oxidizes an other substance. This concept is a bit confusing. Always remember that whatever is a reducing agent itself will oxidize. So a substance that reduces another substance, ठीक है, because it's a reducing agent, reduces an other substance and itself is oxidized. ठीक है, हमेशा एक reducing agent oxidize होता है, oxidizing agent reduce होता है. अब ये थोड़ा confusing है, but you got to get along with this. ठीक है, complete the simple equation by inserting the formula of the missing product and balancing the equation. ठीक है, manganese metal is extracted from M3O4 using aluminum as a reducing agent. मतलब aluminum is gonna reduce it and aluminum is gonna form oxide. ठीक है, aluminum is gonna form oxide and manganese is basically thrown out or is just, is reduced from its ore. So aluminum is gonna form an oxide and aluminum is a 3 plus. ठीक है, remember aluminum is 3 plus, oxygen is 2 negative, so the oxide is gonna be Al2O3. Why? This 3 comes over here, this 2 comes over here, so it's Al2O3. So Al2O3 is going to be the oxide of aluminum. And now you just got to balance it out. How do you balance it? Just for balancing is a hit and trial method. There is no method exactly which tells you how to balance. Just see it, try to figure it out. It's going to be a 4 here, it's going to be a 3 here, and now it's going to be an 8 here, and it's going to be a 3 times is 9, so it's going to be a 9 here. ठीक है, I hope it's balanced. ठीक है, let's move on. MnO2 reacts with dilute hydrochloric acid as shown in this equation. ठीक है, calculate the volume of chlorine gas formed in cm cube at RTP when excess MnO2 reacts with 50 cm cube of 0.2 mole per dm cube HCl. Use the following steps. Calculate the number of moles of HCl. ठीक है, that's easy. We are given with the volume here. We are given with the concentration here. So moles is equal to C into V, concentration into volume. Basically, you take the concentration 0.200 multiplied by 50, but this is in cm cube, and you need the volume in dm cube to get the moles. So you divide this 50 by 1000, and you get your answer. That's going to be 0.200 not 200, 200. That's incorrect if you say this is 200. After decimals, you don't say 200 or 195, you say 195200. That's how you do it. Times 50 divided by 1000. And that's going to give you 0.01 moles. Okay, 0.01 moles. ठीक है, determine the number of moles of Cl2 formed. ठीक है, basically देखें यहाँ पे HCl ratio Cl2. HCl के 4 moles are forming 1 mole of Cl2. ठीक है, HCl ratio Cl2 4:1. These are the moles of HCl. तो अगर HCl के 0.01 moles होंगे तो Cl के x moles होंगे. ठीक है, from this you can easily find by 0.01 divided by 4 equals to x. Divided by 4, and that's going to give you 2.5 into 10 exponent -3, which is going to be 0.0025 moles. Okay, you can write this way as well. This is the scientific way, but you can write this is better because that's going to help you in the next parts. Okay, अच्छा, calculate the volume of Cl2 formed. अब देखें volume का simple formula is basically your moles for gases. ठीक है, for this is only for gases. ठीक है, chlorine is a gas formed. For gases you use this formula. Volume is moles into 24. अब हमें cm cube में moles चाहिए. ठीक है, when you need the moles in cm cube you multiply it by 24,000 cm cube. So moles of chlorine is 0.025 multiplied by 24,000. अब यही अगर dm cube होता तो फिर we would have only taken 24, but not cm cube, so we have cm cube, so we have taken 24,000. So multiplied by and that's going to give you 60 cm cube. Okay, let's move on. Describe a test for chlorine gas. Okay, you got to learn these tests from the table. The test is you take a damp litmus paper, and basically chlorine is your bleaching agent. Okay, chlorine is a good bleaching agent. So basically observation is going to be litmus paper is bleached or fades away. Bleaching basically means your color fades away. Litmus paper is bleached or fades away. Asha, one important thing is that in the old basically in the old syllabus, in the previous syllabus, you had damp blue litmus paper which first turned red and then it's bleached, but according to the recent syllabus update, it's a damp red, not a damp red, not a damp blue, it's only a damp litmus paper. Okay, just go check it out from the syllabus. It's a damp litmus paper, no more a damp blue litmus paper. Okay, previously it was blue litmus paper which first turned red and then it was bleached away, but now it's simply a damp litmus paper which bleaches away. Okay, explain in terms of collision theory why decreasing the temperature decreases the rate of this reaction. Okay, basically when you're decreasing the temperature, decreasing temperature means decreasing the kinetic energy of particles. Collision theory we have to use, so obviously that means less collisions. Okay, decreasing temperature means particles have less kinetic energy, so they move slowly. So they move more slowly and hence less number of effective collisions as they collide less frequently. Acha, this is your 1 point, and in order to get all 3 marks you have to write another point. That is basically when you decrease temperature, what basically happens is your particles become less energetic, and when particles become less energetic, less particles have energy equal to or greater than the activation energy. That means that less frequency of effective collision. Okay, this is very important point. Okay, learn this point. When you decrease temperature, less particles have energy equal to or greater than kinetic activation energy, and activation energy is the minimum amount of energy you need in order for the colliding particles to react. So less particles have energy equal to or greater than activation energy, hence less frequency of effective collisions. Effective collision basically means that your product is formed, okay? And we use the word collisions because of the collision theory in the question. That means we have to use the word collisions. We have to tell the rate in terms of collisions, ठीक है? Effective collision का मतलब होता है your product is formed. और अगर activation energy particles के पास less होगी और less particles would have energy equal to activation energy, effective collisions will reduce and less amount of product is going to be formed. ठीक है? Let's move on to this part, which says the structural formulae of two compounds A and B are shown. This is for A, this is for B. A and B are members of the same homologous series, ठीक है? That means that both are going to have the same general formula, ठीक है? अब homologous series अगर same है, are going to have same functional group, similar chemical properties and trends in physical properties, and every member is going to differ by one methyl unit, ठीक है? अब all this what I'm writing, these are the characteristics of a homologous series, ठीक है? Give two reasons why the structural formula of A and B show that they are members of the same homologous series. अब देखें, A and B में both have the same functional group, which is a double bond, ठीक है? This is the functional group. So how does their structural formula shows? So the first thing is that they have the same functional group. The second thing is going to be that देखें, अगर इसमें हम कार्बन्स काउंट करें 1 2 3, C3 and H is 2 plus 1 plus 3, that's going to be 6, and this is basically C4. देखें 1 2 3 4 and H8, ठीक है? You can count it, or because you know that it's an alkene, so it's going to be the general formula. Basically if you see that their general formula is also same, ठीक है? CnH2n, this is the general formula for alkenes. So both of these structural formulas A and B have similar general formula. देखें, जो हाइड्रोजन है वो कार्बन का डबल है. अगर कार्बन 3 है तो हाइड्रोजन 6 है. अगर कार्बन 4 है तो हाइड्रोजन 8 है. Basically hydrogen is a double of carbon, ठीक है? That's what you got to realize. So it's going to be that they have the same general formula. These are two things basically tell us that these A and B belong to the same homologous series, and if we just calculate the number of carbon atoms 1 2 3, we know this is going to be propene. How do we know it's propene? Because it has 3 carbon atoms and it has an ene because of this double bond, and it has 4 carbon atoms, it's going to be a butene, okay? And it has this double bond as well. Acha, explain why A and B are both hydrocarbons. Hydro means hydrogen and carbon means carbon because they contain elements carbon and hydrogen only. They contain elements carbon and hydrogen only, okay? There's nothing apart from carbon and hydrogen in these two structures, okay? Only carbon and hydrogen. Okay, let's move on. Write the symbol equation for the complete combustion of A. Acha, अब now we have to write the symbol equation for the complete combustion of A. Let's figure out what is A. A is propene, which is C3 and H6, ठीक है? And symbol equation means that we just have to write symbols. Plus O2 is going to form carbon dioxide. देखिए, जब भी हम we have an alkene, we have oxygen, so the products of combustion are going to be carbon dioxide and water. अब now how do we balance it out? देखें, either we have 3 carbons, so over here we're going to put a 3, and how many hydrogen we have? We have 6 hydrogen. We have 2 over here, so we're going to put a 3 over here. Now how many oxygen in total we have? Calculate. 3 2 times 6 plus 3 9 हो गए. अब 9 हमारे पास आ गए हैं हमारे oxygens. When we have 9 oxygen, that means that देखिए यहाँ पे 2 है. In order to balance it out, you have to put a 4.5. 4.5 times 2 is 9. But the problem is we cannot put a 4.5 over here. Why can't we put a 4.5? Because that's not the way we've learned it. We are not, in order to balance anything, we don't use decimals. We don't use decimals in balancing. Especially in O levels, we don't use. So what are we going to do is, देखें ये हमारा 4.5 आ रहा था. Let's write it temporarily. 4.5 आ रहा था. This was basically 3 and this was basically 3 as well. ठीक है, अब हम क्या करेंगे, हम इस पूरी इक्वेशन को मल्टीप्लाई कर देंगे 2 से. 2 से मल्टीप्लाई करने से क्या होगा, when this 4.5 gets multiplied with 2 it becomes 9. So what basically happens is that the decimal gets eliminated. अच्छा यहाँ पे एक 1 है, so 1 multiplied by 2 it will become a 2 over here. 4.5 multiplied by a 2, it's gonna be a 9 over here. So a 9 over here. This 3 multiplied by 2 is gonna be 6. So a 6 over here, and this 3 also gets multiplied with 2 to form a 6 over here. Okay, now you can check it out that it's balanced, and that's how you balance out equations when you have decimals in them. Okay, just multiply the entire equation with 2 or any other number from which the decimal is being removed. Okay, deduce the empirical formula of A. Acha, basically A is your propene, which is C3H6. You cut it out on a table, 3 1 times 3, 3 2 times 6. Okay, let me repeat it, 3 1 times 3, 3 2 times 6. So it is CH2. That's the empirical formula. You just cut it out on a single table, the smallest table you find. Okay, so it's CH2. Name compound B. Acha, compound B basically is butene. Okay, you know it. How do you know it? Because you know it's 4 carbon atoms, 1 2 3 and 4, and there's an ene group over here, so that's a butene. But the problem is that you cannot write butene. Why can't you write? Because if you check out the syllabus, in the syllabus it's clearly written that candidates should differentiate between but-1ene and but-2ene. So basically you should know that either this one is a but-1ene or but-2ene. Achha, how to identify between but-1 and 2ene? Look over here. Okay, this double bond is basically on the, you got to check out the position of the double bond. This double bond is on the second carbon. Okay, if you say that this one's your first carbon, this one's your second carbon, so the double bond is on the second carbon. Okay, between the two second carbons, so that's a but-2ene. Okay, when the double bond is on the second carbon, that's a but-2ene. अगर double bond यहाँ पे होता between, समझ लो CH3 double bond CH2 1 2 3 4, and then it's gonna be CH2 and CH3. अगर ये होता, ठीक है, अगर ये होता, then 3 plus 3 is gonna be 6 7 8 9 10. That makes it a 10, but it should be 8. We've added 2 additional 3 bonds बन रहे हैं, तो यहाँ पे सिर्फ CH होगा. Sorry, it's only CH. 3 4 4, sorry. Acha, basically अब now the double bond is on the first carbon. This is the first carbon, so this is but-1ene. Okay, this is but-1ene because double bond is on the first carbon. Over here this is your first, this is your second carbon, so the double bond is on the second. If you calculate it from this side as well, this is your first carbon, this is your second, double bond is coming on second carbon, so that's a but-2ene. So compound B, you cannot write butene, that's but-2ene. Okay, a structural isomer of B is a member of the same homologous series. Achha, now they're talking about but-1ene. Okay, structural isomer hai but-1ene of but-2ene, and both are of same homologous series. Both belong to alkene homologous series. Okay, so that's but-1ene. Draw the displayed formula of the structural isomer of B. They're talking about but-1ene, so that's going to be a carbon, double bonded carbon. पहले हमने carbon पे बना दिया because it's but-1ene. A hydrogen over here. 1 2 3 4. Just complete the bonds for carbon. 1 2 3 4. Carbon. Okay, a carbon should have 4 bonds. So this is your but-1ene, and it belongs to the same homologous series as butene, but the problem is that it has its carbon double bond on the first carbon, which makes it but-1ene. Okay, let's move on. Compound B reacts with aqueous bromine at room temperature to form compound C. Okay, this is compound B reacts with bromine to form compound C. अब बेसिकली ये कौन सा रिएक्शन है? ये एक एडिशन रिएक्शन है. क्यों एक एडिशन रिएक्शन है? ब्रोमीन ऐड हो रही है ब्यूटीन में टू फॉर्म दिस थिंग. State why this reaction is an addition reaction. अच्छा, now to identify that a reaction is addition reaction, you always have, देखें, after this equals to sign you always have one product. अगर यहाँ पे इसके साथ प्लस कुछ और लिखा होता, फॉर एग्जाम्पल प्लस O2 लिखा होता, तो ये एक एडिशन रिएक्शन नहीं होता, बिकॉज यहाँ पे 2 प्रोडक्ट्स हैं, ये 1 प्रोडक्ट, ये 2 प्रोडक्ट. दिस इज एन एडिशन रिएक्शन बिकॉज you only are forming 1 product. So state why this is an addition reaction. You write only 1 product is formed. Okay, that's why this is addition, because only 1 product is formed, or you can write only a single product. ठीक है, reactants चाहे जितने मर्जी हों, बस product आपका 1 होना चाहिए. ठीक है. Describe the color change in aqueous bromine during this reaction. हमेशा याद रखना, देखें, जब भी कोई डबल बॉन्ड होता है और आप उसमें ब्रोमीन डाल देते हैं ना, कोई भी डबल बॉन्ड होता है, फॉर एग्जांपल CH3 CH2 CH2 double bond CH2 and then CH3. अब ये हमारा 1 2 3 4 ये पेंटीन है. अब इसमें भी एक डबल बॉन्ड है. कब जहाँ पे भी आपके पास डबल बॉन्ड हो और आप उसमें ब्रोमीन डाल दें, तो ब्रोमीन ब्रेक्स दैट डबल बॉन्ड. ठीक है, ब्रोमीन ब्रेक्स दैट डबल बॉन्ड. सो नाउ ओवर हियर द डबल बॉन्ड इज़ ब्रोकन एंड ब्रोमीन हैज़ अटैच्ड. और जब भी ब्रोमीन आप डबल बॉन्ड में डालते हैं, यानी एल्कीन में डालते हैं, यू ऐड ब्रोमीन, द कलर चेंजेस, ब्रोमीन चेंजेस फ्रॉम ऑरेंज और रेड, ऑरेंज/रेड टू कलरलेस. ठीक है, ब्रोमीन्स का ओरिजिनल कलर ऑरेंज या रेड होता है, फिर जब आप इसमें इसको ऐड कर देते हैं, दिस प्रोडक्ट इज़ कलरलेस. नेम प्रोडक्ट सी. अब नाउ दिस वन इज़ अ बिट ट्रिकी थिंग टू नेम प्रोडक्ट सी. लेट्स नेम इट. अच्छा, अब बेसिकली the important thing over here was के this one was your butene. ठीक है, this one was your butene and this one was your bromine, and now you have to name this product. देखें, it has 2 bromines. ठीक है, it has 2 bromines. I'm just breaking it down for you guys. It has 2 bromines, so it is going to be di. Di means 2. Bromo means it has a bromine in it. 2 bromines, dibromo, because of 2 bromines, butane. Why butane? Because it was formed from butene. Butene क्यों था? Because इसमें डबल बॉन्ड था. अब इसमें डबल बॉन्ड नहीं है, डबल बॉन्ड हैज़ बीन फिनिश्ड. ठीक है, ये डबल बॉन्ड अब नहीं रहा, ख़त्म हो गया, तो इट बिकम्स डाई. डाई मीन्स, ब्रेकिंग इट आउट, डाई मीन्स 2, ब्रोमो मीन्स इट हैज़ ब्रोमीन इन इट, एंड ब्यूटेन बिकॉज basically what happened is that this butene lost its double bond. It's no more butene. Ene was because of the double bond and it became dibromobutane. अगर यहाँ पे प्रोपीन होता और इसमें आप ब्रोमीन डाल देते, तो it would have become dibromopropane. अगर यहाँ पे ईथीन होता और आप उसमें ब्रोमीन डाल देते, just learn it, it becomes dibromoethane. ठीक है, so learn this thing. अच्छा, now one important thing over here I'd like to highlight is, देखिए, अब this is not compulsory part of the syllabus, but if you guys understand it's good. अब देखें, यहाँ पे कौन से वाले कार्बन पे हमारा ब्रोमीन अटैच हुआ है? दिस इज़ द सेकेंड कार्बन. ठीक है, सेकेंड कार्बन पे ब्रोमीन बेसिकली अटैच्ड है, और ये वाला कार्बन जिस पे अगला ब्रोमीन अटैच्ड है इज़ द थर्ड कार्बन. सो यू कैन राइट 2,3 dibromobutane as well. ठीक है, दिस इज़ बेसिकली द करेक्ट थिंग. यू कैन राइट दिस 2,3 if you are able to figure it out कि कौन से कार्बन पे है, but if you are not, then dibromobutane will do the job. So if it would have been for 2 marks, you could write 2,3 as well, but I don't think that's part of the syllabus. Just write dibromobutane. So you can write 2,3 if you want, but that is the correct way to write it. 2,3 का मतलब है 2 पे पहला ब्रोमीन, अगला ब्रोमीन 3 पे, डाइब्रोमो का मतलब 2 ब्रोमीन्स, और ब्यूटेन का मतलब it has 4 carbons in it. Under certain conditions, 1 mole of B ठीक है. B, what is B? B is basically your butene. ठीक है. Reacts with oxygen to form 2 moles of carboxylic acid D. Carboxylic acid D has 2 carbon atoms. ठीक है. Draw the displayed formula of carboxylic acid D. 2 carbon atoms कौन से acid में होते हैं? Which acid has 2 carbon atoms? Quickly figure it out. Ethanoic acid. How do we draw the displayed formula of ethanoic acid? Carbon double bonded O, H, 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 H. That's ethanoic acid. ठीक है. Name the carboxylic acid D. That's simply ethanoic acid. That was simple. Complete this simple equation for this reaction. अच्छा, अब हो क्या रहा था कि हमारा under certain condition 1 mole B का react कर रहा था ऑक्सीजन के साथ यानी O2 के साथ to form 2 moles of this carboxylic acid D. 2 moles of ethanoic acid. Ethanoic acid is CH3COOH. अच्छा, अब now you have to know this thing. देखिए O2 है ना, O2 यहाँ पे 2 लिखा है तो मतलब 4 ऑक्सीजन हो गई इन टोटल इस पूरे इसमें. तो यहाँ पे भी आप एक 2 लगा दें. सो दिस इज़ बैलेंस्ड नाउ. ठीक है. That is simple balancing which I have done. And here we come to the end of the paper. I hope you liked the video. If you do, then subscribe to the channel and like it. Thanks for watching. Bye.